Introducing the Augmented Newtonian Dynamics theory on radio waves. Revealing the true nature of the invisible threads that bind our world. Radio waves power our entire civilization. They carry our voices, our money, our news, and our defenses. Without them, the modern world would collapse into silence. And yet, here is the paradox. Science has no true physical explanation for radio waves. We can measure their frequencies, we can map their wavelengths, and we can record how they propagate across space, but this is little more than bookkeeping. Just as with gravity, we rely on observing effects and building mathematical theories around those effects, but the underlying mechanism remains unknown. We know how radio waves behave, but not what they actually are. We can predict their motion, harness their power, and even send them across the solar system, yet we cannot say, in physical terms, what they consist of. This is a science built on observation without testing, description without understanding. It gives us equations that work, but not explanations that satisfy. At the most basic level, we still cannot answer the simplest questions. How are radio waves formed inside matter? By what process do they propagate through the emptiness of space? Why do they display the precise properties they do? It is precisely here, at the gap between prediction and explanation, that Augmented Newtonian Dynamics steps in to offer an answer. An answer that is practical, grounded in reality, and yet fulfills every criteria. The origin of radio waves has been given many different explanations. They have been attributed to the spin of the electron, to its motion around the nucleus, even to subtle vibrations of the atom itself. Yet none of these theories are truly satisfactory. The most recent attempt has been made by quantum field theory. In this abstract framework, radio waves are linked to the vacuum itself, to so-called zero-point energy. With its mathematical machinery of creation and annihilation operators, QFT conjures photons into existence, orders them to vanish, and then recreates them again. It is a dance of symbols on paper, but one that leaves us no clearer about how radio waves are actually produced in nature. These eccentric explanations arise not from clarity, but from desperation. The reason is scale. Light, with its higher frequencies and shorter wavelengths, can be emitted and absorbed by electrons bound inside atoms. That picture at least makes sense. But radio waves are different, they are vast. Consider the classical diameter of the electron, about 2.8 by 10 to the power of -15 meters. Now compare it with a radio wave 5 million meters long. The difference in scale is staggering, on the order of 10 to the power of 21. This is a difference in size, measurable not in terrestrial terms but in light years. To grasp this, imagine the electron blown up to the size of a grain of sand. At that scale, a single radio wave would stretch across an entire galaxy. No matter how long or hard an electron might oscillate, it cannot, by itself, generate something of such immensity. An object that, in comparison, is the size of the galaxy. The other oddity that physicists have to face is the fact that, leaving aside the disparity in size, the other properties of radio waves are identical to that of photons. They are massless, they always propagate at the speed of light in a vacuum, they spread out according to the inverse square law, they maintain their original energies across vast distances of space. The question that faced physicists was, how are radio waves explained? What is the in-theory explanation for radio waves? To answer this, one must first understand that Augmented Newtonian Dynamics places a limit on the maximum size photon that an electron can emit. These are the lowest energy, lowest frequency photons, what in theory calls conduction photons. Conduction photons are emitted by free electrons in a conductor when a potential difference is applied. And here lies the radical departure. For more than 200 years it has been believed that electrons themselves are the charge carriers in an electric current. And theory overturns this. It holds instead that it is photons, conduction photons, that carry the current. How is this possible? The answer lies in the Heisenberg uncertainty principle as it applies to energy and time. If the energy involved in an interaction is sufficiently small, or the time over which it occurs sufficiently brief, then the interaction may bypass the conservation laws of energy and momentum. This provision allows a free electron to emit a conduction photon, provided that it reabsorbs that photon, or another of equal energy, within a very short time. Thus, free electrons in a conductor are limited to emitting and absorbing conduction photons. Photons of higher energy would create uncontrollable recoil, while photons of lower energy could not be emitted at all. This, according to in theory, is how current flows. And this same process explains how vast numbers of conduction photons link together, giving rise to the radio waves upon which our entire civilization depends. What is a radio wave in AND theory? To answer this, we must first understand how current flows in a conductor. Inside a wire at room temperature, conditions are chaotic. Free electrons, unconnected to any voltage, rush in random directions at speeds of 1,000,000 meters per second. They collide constantly, with each other and with the crystal lattice of the metal. But when a potential difference is applied, order begins to emerge. The electrons acquire an average motion in one direction, what we call the drift velocity of the current. This drift is astonishingly slow, only millimeters per second. Yet at the same time, free electrons begin to emit conduction photons. And these photons are always emitted in the direction of the drift velocity. Neutrality is a law of nature. Even the gain or loss of a single electron matters. So when trillions of conduction photons are emitted, chaos reigns. The electron that emitted one photon cannot reabsorb it. Instead, it absorbs an identical photon emitted by another free electron. What happens to the first photon? Often, it finds no electron nearby able to accept it. To resolve its energy, it escapes the conductor, where it encounters the photon ether. There, virtual photons align into concentric lines around the wire. Each concentric line of force contains the energy of one conduction photon or 1 eV. These are the familiar lines of force observed around any current-carrying conductor. For a direct current, that is the end of the story. But with alternating current, the story is very different. As long as the current flows steadily in one direction, photons can be emitted and reabsorbed without difficulty. But when the current reverses polarity, everything changes. A rush begins. Photons outside the conductor surge inward, desperate to resolve their energy. Those nearest succeed, and discharge into the earth. This is why a spark leaps when an appliance is unplugged without a switch. But what of the photons farther out, locked in the lines of force? They cannot reach the conductor, and yet they must resolve their energy. At first, they are connected in series, forming the concentric loops that surround the wire. In this configuration, connected in series, each line of force carries the energy of a single conduction photon or 1 electron volt. But, when the concentric circles of series-connected photons are too far away to have any chance of reaching the conductor and resolving their energy, they reconfigure into a parallel formation. Photons connected in parallel share the energy of a single conduction photon across the number of conduction photons present. This is the reason radio waves possess so little energy. The photons in the far field link together in parallel chains and leave the vicinity of the conductor at the speed of light. In doing so, they become radio waves. Radio waves are nothing more and nothing less than flying currents of electricity, vast assemblies of conduction photons, bound together in parallel. Their frequency, their wavelength, and their energy are determined entirely by the switching time of the alternating current. As Tesla glimpsed 100 years ago, currents themselves can take flight. And that flight is what we call a radio wave. Radio waves. Invisible, tireless, indispensable. They carry our voices, our money, our knowledge, and our security. They bind civilization together. Yet for more than a century, their true nature has remained unexplained. Augmented Newtonian Dynamics offers that explanation. It reveals that radio waves are not abstract oscillations of a field, but vast streams of conduction photons, the lowest energy photons electrons can emit, linked in parallel and launched into the cosmos. They are flying currents of electricity, exactly as Tesla once envisioned, woven through the fabric of the photon ether. And so, the mystery resolves into clarity. The lines of force we see around a conductor, the sparks that leap from a socket, the signals that cross oceans and span galaxies, all are the work of conduction photons. Radio waves are not only the pulse of modern civilization. They are also the proof that the universe itself is built on the photon ether, and that every current, every spark, every wave carries the hidden order of nature.